Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in the last class we were discussing the chapter polynomials. Let's go for continuing this, and this is second period of this chapter. In yesterday's class we got the basic information about the chapter polynomials. If you want to recall some of the important points from them, the very first one is definition of polynomial. So chance of asking in the examination as well. Yes, recall the definition of polynomial. You can define this as an algebraic expression involving the variable whose power is non-negative integer. Right? The given polynomial, it may be in any variables. It may be in the variable x, y, z, a, b and so on. If the polynomial is in x, we write it as p of x. Y and p of y, z, p of z, right? I go for taking just one example for polynomial. It is 2x square minus 5x plus 13. This is a polynomial. Then here, what do you call 2x square, 5x and 13? These are called terms of polynomial, right? Then here, what do you call 2 minus 5 and 13? They are all called coefficients. And here 2 is called the coefficient of x square, 5 is called coefficient of, minus 5 is called coefficient of x, and 13 is just constant or coefficient of x raised to the power 0, right? Then based on the number of terms in the polynomial, we have classified the polynomial as monomial, right? Mono means one. A polynomial having one term only. Binomial, that is a polynomial having two terms. Trinomial, polynomial having three terms. Then more than three terms, we go for calling it as multinomial. Is it not? Next. After this, we focused on the highest power of the variable involved in the polynomial. What it is called? Yes, you are right. This is degree of the polynomial. Once I tell the definition, it is also important one. The highest power of the variable involved in the polynomial is called degree of the polynomial. Even based on the degree, we have classified the polynomial into some types. Then in that first one, what do you call a polynomial of degree 1? It is called linear polynomial. What is its general form? It is ax plus b where a is not equal to 0. Then what do you call a polynomial of degree 2? It is quadratic polynomial. Then recall its general form. It is ax square plus bx plus c where a is not equal to 0. And the third one, it is a polynomial of degree 3. Name it cubic polynomial, and its general form ax cube plus bx square plus cx plus d where a is not equal to 0. Even we have given a definition, examples and all with respect to all the three. You had written up to here, is it not? Okay, now let us start today's class by continuing the types of polynomial. Now I'll write here. Now we are moving to fourth one, that is a polynomial of degree 4. What it is called? It is called biquadratic polynomial. Yes, just to recall the definition of biquadratic polynomial. Here are right. It is a polynomial of degree what? Yes, degree 4. A polynomial of degree 4 is called biquadratic polynomial. And tell the general form or standard form of this biquadratic. We can write it as a x raised to the power 4 plus bx cube plus cx square plus dx plus E, where A is not equal to 0. If A becomes 0, A x raised to the power 4 term gets cancelled. The remaining terms will form a cubic polynomial. Clear? Now I will go for writing the example for this. Then here example x raised to the power 4 minus 2. I will go for one more. It is 2 x raised to the power 4 minus 3x plus 11. Next 13 x raised to the power 4 minus 2 by 3 into x. See, all these are examples for biquadratic polynomial. Understood? So we have given the names for different types of polynomial based on their degree. Suppose a polynomial has a degree n. What it is? It is n polynomial. Here I am going to write. Look here. Polynomial of degree n. It is n polynomial. If it contains the variable x, we write it as p of x. Then how do you write the general form? Yes, students, we can go for writing like this. Look here. It is a0 x raised to the power 0 plus a1 x raised to the power 1, a2 x raised to the power 2, a3 x raised to the power 3, and so on. The nth coefficient can be written as an, and variable can be written as x raised to the power n. Clear? And this is the standard form of the polynomial. Clear? Here, observe that highest power is n. That's why I told you it is n polynomial. Actually, you no need to write x raised to the power 0 because it is 1. Only for the sake of remembering and written so. Here, what do you call x may be power 0, 1, 2, 3 and so on up to n. What is it? It is variable. Then what do you call 0, 1, 2, 3 and so on up to n? They are non-negative integers. Here right. 0, 1, 2 and so on up to n. They are all non-negative integers. Next, observe a0, a1, a2, a3 and so on. Last one, an. What do you call them? They are all the coefficients of these x raised to the power 0, x raised to the power 1, x raised to the power 2 and so on, x raised to the power n respectively. Clear? So here I write a0, a1 and so on, an. They are all coefficients, and these coefficients are real numbers. In bracket I write. They are all real numbers. Next. Dear students, I will give you one more information. I am going to write sum of the polynomials. Observe them. It is 3, 10, minus 11, 2 by 3. Do you call them as real polynomials? Of course. Or even any number may be. That is also a polynomial. Then what about its degree? Its degree is 0. What do you call a polynomial of degree 0? It is, yes, it is called constant polynomial. Here I write constant polynomial. And definition for this: a polynomial, or it is a polynomial of degree. Polynomial of degree. How much? 0. Then what about its general form? It is just we write a, where a is a real number. example for this. You may go for taking 22 by 7, 10, minus 3 and so on. Got it? Dear students, now you have to write the definition of biquadratic polynomial, copy up to here, then write the side heading polynomial of degree n, then copy up to here. After this, you come back to constant polynomial. Now, I'll ask you one more simple question. Here, 0 is there. What is the degree of this 0? Degree of 0 here will not be defined because 0 into anything is 0. So, that 0 polynomial, degree of 0 polynomial cannot be defined. You remember that point. Yes, copy up here. Pausing the video, copy from there to here. Just we have completed about the different types of polynomials. And little bit information is there. Just observe here. Degree of constant polynomial, we are very familiar with that. It is 0. Constant polynomial means except 0, you can go for taking any number like 7, 10, minus 11, 15, 2 by 3, root 10. They are all constant polynomials. Their degree is 0, right? Then another one. Degree of 0 polynomial is not defined. That is, except these numbers, I'll go for take 0. What is its degree? So its degree is not defined. Clear? So this is a 0 polynomial. 0 polynomial, its degree is not defined. Remember. And polynomial may be having more than one variable. Just I go for writing sum of the polynomial. Observe it. Here it is x plus 2. Then 2x plus 3y minus 10. Then 2x plus y minus z plus 15. Observe, all these are polynomials. In first polynomial, we have the variable x. How many variables are there? There is only one variable. So we can call it as it is a polynomial in one variable. Clear? Next. Observe this one, second polynomial. 2x plus 3y minus 10. Here we have the variables x as well as y. There are two different variables. Hence you can call it is a polynomial in two variables. Whereas in this case, it is a polynomial in three variables. What do you say about this? X square plus 5x plus 6. It is a polynomial in 1, 2 or 3 variable. It is one variable only because there is only x. Got it? Here I am going to take the examples for third point. X plus 2 is a polynomial in one variable. And second one, it is a polynomial in two variables. Third one, it is a polynomial. And how many variables are there? 3. In 3 variables. Got it? Whereas fourth one, this is also polynomial, only degree is changed. Degree is 2. Is a polynomial. And it has only one variable, that is x, in one variable. Next. So based on this, what we have learned so far, we have questions in exercise 2.1. Let's move on to that. In that first question, observe this one. Which of the following expressions are polynomials in one variable and which are not? First you go for identifying whether it is a polynomial or not. If it is polynomial, then you can tell whether it has one variable or two variable or more than two variables. Next, state the reason for your answers. Let's go for answering one by one. First one, 4x square minus 3x plus 7. Is it a polynomial? Yes. How do you say that? Because power of the variable is non-negative integer. Therefore, it is a polynomial. And how many variables are there? There is only one kind of variable, that is x. Okay, here also x, here also x. Understood? Here I'll write. It is a polynomial. Polynomial in one variable. Then you have to give the reason, state reason for your answer. How do you say? Because it has the variable x only. Because it has the variable x only. Observe this. Second one. Y square plus root 2. Is it a polynomial? 100%. Because power is non-negative integer or whole number. Therefore, we can write it is a polynomial. Then how many variables are there? There is only one variable, y. So you can write it is a polynomial in one variable. Then reason, same thing. Because you can write it has the variable, which is that variable? Y only. Now come third. Third one is 3 into root t plus t into root 2. Is it a polynomial? No. How do you say that it is not? Because when you are rewriting this, we can write root t as 1 by t raised to the power 1 by 2 plus t is root 2. T into root 2. It is not a polynomial. The reason is power is not non-negative integer. Here I write. It is not a polynomial. Not a polynomial because the power of the variable is not a non-negative integer. Non-negative integer. Clear? Yes. Now let's move on to fourth one. Y plus 2 by y. There is one variable, but first identify, is it a polynomial in one variable? Firstly, it is not at all polynomial. Observe, the reason is y plus 2 by y can be rewritten as y plus 2 into, take y to the numerator, y raised to the power minus 1. So power is not a non-negative integer. Therefore, it is not a polynomial. Here I write. It is not a polynomial. If it is polynomial, then only you can tell that whether it has one variable or two variables. It is not a polynomial because the power is, or power of the variable is not a non-negative integer. Got it? Now, I'll go for taking fifth one. Here I have written x raised to the power 10 plus y raised to the power 3 plus t raised to the power 50. First you tell that whether it is polynomial or not. 100% it is a polynomial because powers are positive integers. Got it? Our powers are whole numbers. Therefore, it is a polynomial. Is it in one variable? No. Because it has three variables, x, y and t. Got it? So, here I will write. It is a polynomial but not in one variable. What is the reason? Because Because it has three variables. What are those? They are x, y and t. Clear now? Hope that you have understood. Dear students, now you have to copy from here to there. First in note, you take these 3 points and these are the examples for third point. After that, you go for writing exercise 2.1 and we have answered for all the sub questions in first question. Just copy this. Now, we have few more questions. Second one, third one and fourth one I have written. Let's go for answering one by one. Exercise 2.1, this is second one. Write the coefficients of x square in each of the following. They have asked you to write the coefficients of only x square. Here, I have taken the first one. 2 plus x square plus x. Here, the x square term is this is. What is its coefficient? Nothing is there. It means there is 1. Coefficient of x square is 1. We can write. So, coefficient of x square is 1. Let's go for second one. Identify the x square term. This is minus x square. What is its coefficient? It is minus 1. Here I write. Coefficient of x square is minus 1. Then, third one. This identify the x square term. It is pi by 2 x square. Hence, the coefficient of x square is pi by 2. Next, another one. Observe, here there is no x square term. Then what do you write? You can rewrite this as, there is x square term is not there. It means 0 into x square. What is 0 into anything? 0. 0 into x square plus root 2x minus 1. Now, identify what is the coefficient of x square. Here it is 0. Got it? Now, let's go for third. Very simple. Give one example each of a binomial of degree 35. Binomial of degree 35 and a monomial of degree 100. Dear students, we know what are binomial and what are monomial. Binomial is a polynomial having 2 terms. Then monomial, a polynomial having single term. Let's go for giving examples for this. First one, example for binomial of degree 35. Binomial of degree 35. You can give plenty of examples. Degree 35, x raised to the power 35 plus 2. How many terms are there? There are 2 terms. You may go for taking some more example. 7 y raised to the power 35 plus 2y. How many terms are there? 2 terms are there. Highest power is 35. That is the degree 35. Like this, you can give plenty of examples. I'll go for next one. A monomial of degree 100. Monomial of degree 100. Here, example. I'll write x raised to the power 100. One example. Then 2 by 3 x raised to the power 100. Now minus 11 by 2 y raised to the power 100. See that these are all monomials with degree 100. Clear? Only single term is there. Next, fourth question. This is also very simple. Go through this one. Write the degree of each of the following polynomial. What is the degree of the polynomial? It is highest power of the variable involved in the polynomial. Right? So now let's go for answering these. First one. Variable, it is x. The powers are 3, 2, here is 1. Highest power is 3. Therefore, degree is 3. Degree is 3. Next one. What is the degree of second polynomial? 4 minus y square. There is only one variable y and its power is 2. That is only highest. Hence, degree is 2. What about in this case? 5t minus root 7 into x raised to the power 0. Sorry, or t raised to the power 0. T raised to the power 1, t raised to the power 0. Highest power is 1. Therefore, degree is 1. Understood? And this is, it is a constant polynomial. 3 can be written as 3 into x raised to the power 0. What is the highest power of the variable? 0. Hence, degree is 0. Dear students, you know that degree of any constant polynomial is 0. Clear? Yes. Please go for writing from there to here. Write neatly. First you go for second one, then third one and fourth one. Now this is fifth one. It is the last problem in last question in exercise 2.1. Go through this. Very simple. Classify the following as linear, quadratic and cubic polynomials. They have given total 7 polynomials. We have to divide them into linear, quadratic and cubic polynomials. Dear students, we know what are these. Linear is a polynomial of degree 1. Quadratic, a polynomial of degree 2. And cubic is a polynomial of degree 3. Right? Now let's go for classifying. And for the sake of classification, I am going to make 3 columns. First column for linear polynomials, second one for quadratic polynomials and third one for cubic polynomials. Here, look at them. Observe it in first polynomial. X square plus x is there. Which polynomial? You have to identify the degree. Highest power of the variable is 2. A polynomial of degree 2 is called quadratic. Therefore, x square plus x is quadratic polynomial. Here on right. This is x square plus x. This is first one. Next, second one, let us say where it belongs. X minus x cube. Highest power is 3. Nothing but degree is 3. Therefore, it belongs to cubic polynomial. It is x minus x cube. X minus x cube. Now, third one, y plus y square plus 4. Degree is 2. Therefore, it is a quadratic polynomial. So, third one belongs to quadratic polynomial column. Y plus y square plus 4. Next, fourth one. 1 plus x is there. What is the highest power? 1. Power of x is 1. Degree is 1. A polynomial of degree 1 is, it is linear polynomial. So, fourth one belongs to linear polynomial. Next, fifth one. 3 into t. Variable involved, t. Power 1. Highest power 1. What type? It is linear polynomial. So, fifth one, 3 into t belongs to linear polynomial. Next, sixth one, r square. Variable involved, r. Power is 2. Which polynomial? Quadratic. So, here I'll write sixth one in quadratic polynomial column. 7x cube. Only one variable, x. Power is 3. Highest power 3. Degree 3. What type? It is cubic. So 7x cube. Seventh one, 7x cube belongs to cubic polynomial. Got it? Dear students. So you have to make a table of this. And you have to use scale and pencil and prepare a table like this. In that there must be 3 columns. One for linear, one for quadratic, another for cubic. Okay. Yeah. Now you have to copy from there to here. Next we are moving to very interesting concept. And before that, just pause the video and copy from there to here quickly. Dear students, now we are moving to the next concept. Two important concepts which are interrelated. And for explaining this, just I am going to take a simple example for polynomial. It is x plus 2. Correct? It is the given polynomial. Now, could you tell what happens when 0 is placed in place of x? Let's see that. I call this as polynomial in x, p of x, which is equal to x plus 2. If I take 0 in place of x, it becomes 0 plus 2, which is equal to 2, right? See, 0 is written in place of x, then plus 2, 0 plus 2 is 2. Then I take 1 in place of x, then it is 1 plus 2, this is 3. Next, I take minus 1, this is equal to, observe, it is minus 1 plus 2, it is plus 1. Similarly, let us take p of 2, in place of x, I am substituting 2. 2 plus 2, it is 4. Let us go for taking minus 2. When you substitute minus 2 in place of x, minus 2 plus 2, how much it is? 0. Right? Let me go for taking one more example. X square plus 5x plus 6. This is the given polynomial. Even this is also in x, hence I go for writing this as p of x. It is equal to x square plus 5x plus 6. Here also I am going to take some values in place of x. So if it is 0, p of 0, now observe 0 whole square, 5 into 0 plus 6. What is 0 whole square? 0. 5 into 0, 0 plus 6. 0 plus 0 plus 6. It is 6. Then p of 2. Let us take 2 in place of x. Observe here 2 whole square plus 5 into 2 plus 6. What is 2 square? It is 4. 5 2s are 10 plus 6. 4 plus 10 plus 6. It is 20. I take one positive, another negative one will be taken. P of minus 2. Let me substitute minus 2 in place of x. So minus 2 whole square plus 5 into x is there. Minus 2 plus 6. It is equal to minus 2 whole square is 4. 5 into minus 2, it is minus 10 plus 6. What is 4 plus 6? 10. 10 minus 10? 0. Right? I go for one more value, p of minus 3. It is minus 3 whole square plus 5 into minus 3 plus 6. It is equal to minus 3 whole square is 9. 5 into minus 3, minus 15 and plus 6. What is 9 plus 6? 15. 15 minus 15? 0. Got it? Now you observe these. P of 0, that's equal to 2. P of 1 equal to 3. P of minus 1 equal to 1. P of 2 equal to 4. And P of minus 2 equal to 0. Here, whatever we have got 2, 3, 1, 4 and 0. These are called the values of the given polynomial when x is 0, 1, minus 1, 2 and minus 2. Clear? Similarly, come across this with respect to this polynomial. P of 0 is 6. P of 2 is 20. P of minus 2 is 0. P of minus 3 is equal to 0. Here 6, 20, 0 and 0. These are all the values of the given polynomial when 0, 2, minus 2 and minus 3 are taken in place of x. Clear? So this is the method of finding the value of the given polynomial for the given value of variable. Now I am going to encircle sum of the values. Observe, where the value we have got 0 and here we have got 0, here we have got 0. Look at here, the value of the polynomial x plus 2 is 0 when x is minus 2. Got it? And here the value of the polynomial x square plus 5x plus 6 is 0 when x is minus 2, is 0 when x is minus 3. And these are the values of variables which make the value of polynomial 0. Here, this is the value of the variable which makes the value of the polynomial as 0. Do you know what we call the value of the variable which makes the value of polynomial as 0? Yes, it is called 0 of a polynomial. I hope that you have understood. 0 of polynomial. Once I tell you the definition, the value of a variable which makes the value of the polynomial as 0 is called 0 of the polynomial. Here, in this case, minus 2 is called 0 of x plus 2. Here, in this case, minus 2 as well as minus 3 are the zeros of x square plus 5x plus 6. Got it? Now, dear students, you have to write the side heading value of a polynomial. Value of a polynomial. Then, here first question I take, find the value of the following polynomials. Following polynomials as indicated. The first question is, in that first sub question is x plus 2 where x equal to 0, 1, minus 1, 2, minus 2. So this is the solution. Okay, you have to copy from here up to here. So this is 2 is the value of p of 0, 3 is the value of p of 1, then 1 is the value of p of minus 1, 4 is the value of p of 2 and 0 is the value of p of minus 2. Got it? Similarly, you will go for copying even second one also. Second one is x square plus 5x plus 6 when x is, we have taken 0, 2, minus 2 and minus 3. You have to assume that p of x equal to given polynomial, then find the value of p of 0, p of 2, p of 2, then p of minus 2 as well as p of minus 3. After that you have to write the definition. Later I will write it. You please go for copying from there to here. Now let's go for finding the values of these three polynomials. When x is, they are given x equal to 1 for this polynomial, y equal to 2 for the fourth one polynomial and t equal to a for the fifth polynomial. Very simple. Just substituting here on the right. When x equal to 1, I'll substitute. Okay, p of 1 equal to 5 into 1 whole square minus 3 into 1 plus 7. What is 1 square? 1. 1 into 5? 5. Minus 3 into 1? Minus 3 plus 7. Then 5 minus 3? 2. 2 plus 7, it is 9. So P of 1 is 9. Got it? Next. This is fourth one. Here they have given the polynomial in y. So y is 2. Now polynomial q of y is 2. It is equal to 3 into 2 whole cube minus 4 into y is 2 plus root 11. It is equal to 3 into what is 2 cube? 2 into 2 into 2. 2 2s are 4. 4 2s are 8. Then minus 4 into 2. 4 2s are 8 plus root 11. This is equal to 8 3s are 24 minus 8 plus root 11. 24 minus 8, it is 16 plus root 11. So q of 2 is equal to 16 plus root 11. Got it? Next. This is also very simple one. Here the polynomial is given in the variable t and t is a. Here I'll write when t equal to a, then p of, in place of t we should write a, then 4 into a whole raised to the power 4 plus 5 into a whole raised to the power 3 minus t in place of t a whole square plus 6. It's equal to a whole raised to the power 4 means a raised to the power 4 a raised to the power 4 5. A cube means, sorry, a whole cube is a cube minus a whole square a square plus 6, and this is the value of p of a. Got it? Such a simple one it is. Yeah. Please go for copying from there to here. Yeah. Dear students, just earlier only I explained you about 0 of a polynomial. Here I have written the definition. Once you go through that, look here. The value of a variable in the polynomial makes the value of polynomial 0 is called 0 of a polynomial. We had already taken one example that you might have remembered. This is the polynomial x plus 2. This is p of x equal to x plus 2. We had taken minus 2 in place of x is equal to minus 2 plus 2 is equal to 0. Look here. Here minus 2 is called 0 of this polynomial because when you substitute minus 2 in place of x, the value of polynomial becomes 0. Clear? So this is one example. Here I'll write. Example 1 is minus 2 is a 0 of x plus 2. You can give the reason because here p of x equal to x, let p of x equal to x plus 2, p of minus 2 equal to minus 2 in place of x, minus 2 plus 2, 0. Got it? Similarly, I go for taking one more example. Here second one, you might have remembered that x square plus x 5x plus 6. How many zeros it has? It has 2 zeros, right? Minus 2 and minus 3. In both the cases, the value was 0. I take any one. Second example, let us take minus 2 is, or minus 3. Minus 3 is a 0 of x square plus 5x plus 6. How to say that it is a 0 of the polynomial? If it is a 0, when it is substituted in place of x, the value of the polynomial should be 0, right? Here observe, because here I am going to take, let p of x equal to x square plus 5x plus 6. It is a polynomial, and where x is minus 3, p of minus 3 equal to, it is minus 3 whole square plus 5 into minus 3 plus 6. What is minus 3 whole square? Is 9. 5 into minus 3, minus 15 plus 6. 9 minus 15 minus 6 plus 6. Minus 6 plus 6, 0. See that? The value of the variable x, that is minus 3, has made the value of polynomial as 0. Therefore, minus 3 is called the 0 of the polynomial x square plus 5x plus 6. Got it? Then you all may be thinking that it is when a polynomial is given, how to find out its 0? Now I go for teaching you that. That is method of finding the 0 of the given polynomial. Very simple. So before that, you just copy from there to here. Dear students, now let us come to know how to find out the zeros of the given polynomial. Just I have taken simple examples other than NCERT text. With a question. The question is, find the zeros of the following polynomial. First one, which is most familiar to us, x plus 2. We have already come to know what is the 0 of x plus 2. Yes, you are right. It is minus 2. But how to get that minus 2? I'll tell you that. Observe it. This is the polynomial x plus 2. You are going to find out the 0 of this polynomial. Hence, the given polynomial should be equated to 0. Then solve. What is the variable involved? It is x. Solve it. X equal to transfer plus 2 to the right hand side, minus 2. Therefore, minus 2 is called 0 of the polynomial. Got it? Therefore, minus 2 is the 0 of given polynomial. Here, given polynomial. Next, let me go for taking second one. Even this is also very simple. 3x plus 1. To find out the 0 of this polynomial, what is the first step to be followed? You are right. It should be equated to 0. Then 3x is equal to transfer 1 to the right hand side becomes minus 1. Solve x. Transpose 3 to the denominator of the RHS. Minus 1 by 3. Clear? So when you substitute minus 1 by 3 in place of x, 3 get cancelled. Minus 1 plus 1 becomes 0. Clear? Therefore, we can say the 0 is minus 1 by 3. I'll take this one. 5x minus 3. Take the first step. 5x minus 3 should be equated to 0. Then first solve 5x. 5x equal to 0. Transfer minus 3 to the right hand side. It becomes plus 3, then 5x, it is equal to 0 plus 3 is 3, solve x, x equal to 3 by 5. Next, I am taking only the polynomials having variable x. So you find it very comfortable to understand. X equal to 3 by 5. This is the 0. You can check that. Look here, 5x minus 3. Substitute minus 3 in place of x. 5 into 3 by 5 minus 3. 5 get cancelled. 3 minus 3. 3 minus 3, 0. So therefore, the 0 of given polynomial is 3 by 5. Next, let's go for taking another one. It is fourth one. 3 minus 7x. Now, here I write 3 minus 7x should be equated to 0. We need x, right? So, as it is minus 7x, transfer this to the right hand side. 3 is equal to minus 7x becomes plus 7x. Then interchange LHS and RHS. So, there will be no change in the sign. 7x equal to 3. Then x equal to 3 by 7. Therefore, the 0 is 3 by 7. Clear? I'll just go for taking one more. Fifth one. Suppose ax plus b is given. How do you find out? Same method. Ax plus b should be equated to 0. Then solve Ax. Then transfer b to the right hand side. Minus b. Then solve x. X equal to minus b by a. Therefore, the 0 is minus b by a. Understood? Yeah, still some more are there. Let's go for solving them. You just copy from there to here. Pause the video, copy that quickly. Now, let me go for taking one more. That is 6th one. It is 3 by 2x plus 7 by 4. Then how to find out the 0 of this polynomial? Again, finding the value of x by equating this to 0. I'll write it. 3 by 2x plus 7 by 4 should be equated to 0. Next, here I'll write 3 by 2 into x, transfer 7 by 4, constant to the right hand side, minus 7 by 4. Clear? We want only x. X equal to minus 7, cross multiply. 7 should be multiplied with minus 7, 3 should be multiplied with 4. Here you can go for cancelling, see that 1s are 2s are. Now x equal to minus 7 as it is, 2 3s are 6. Therefore, the 0 is minus 7 by 6. Understood this? Okay. Dear students, observe all these polynomials. Could you tell what is their degree? All the polynomials. X plus 2, 3x plus 1, 5x minus 3, 3 minus 7x, ax plus 3, 3 by 2x plus 7 by 4. Their degree is 1, right? Then what type of polynomials are these? They are all linear polynomials. Then observe how many zeros they have? Only one. Okay, first polynomial x plus 2. It has only one zero, that is minus 2. Second, it has only one zero, minus 1 by 3. Like that. Clear? One thing. And you all may be thinking that if quadratic polynomial is given, how to find out their zeros? Yes? Yeah. Now, dear students, let's go for finding the zeros of quadratic polynomial in tomorrow's class. Okay? And before concluding the class, again, I'll remind you, whatever the syllabus we have covered today, please work out today itself without fail. Don't keep anything pending. And tomorrow also, we have very interesting concepts, that is finding the zeros of quadratic polynomial and some of the cubic polynomial, then factorization, which you have learnt in your previous classes. Such interesting concepts are there. Let us go for learning them in tomorrow's class. So with this, let us stop the class. Thank you very much.